Hello, everyone. How are you doing? I trust you are all doing great. James from JTS Maths Tutoring here. Today, we continue looking at algebraic properties of matrices. Let's get going. Suppose A, B, and A plus B are all n by n invertible matrices. Prove the following. All right. Right, multiply both sides by the sum of the inverse of A and the inverse of B. So we know that if we do this side, we're actually going to get an identity matrix. And we are saying if we do it the same with this side as well, we must get an identity matrix. That way would actually have proved that this is the case. All right, let's get going. So distribute B into the sum of the inverse of A and the inverse of B on the right-hand side. So that is what you get when you distribute B right there. All right. And we know when you multiply a matrix with its inverse, you're going to get an identity matrix. Right, this is what we have right here. So I want to have a common factor here. So you can see exactly what I'm doing here. I've not changed anything. It's still an identity matrix. Right now, I've managed to have that right here. So what I'm actually going to do here is now, if you factor out the inverse of A, and then you apply the properties A plus B is equal to B plus A, that is the commutative property of the sum of matrices there. And we know that if you multiply a matrix with its inverse, it's going to give you an identity matrix and vice versa. All right, so this is what you have done. You've factored out the inverse of A here. And we can see right here, what we have right here is that when you multiply this 2, you're going to get an identity matrix. Then you'll be left with A multiplied by the inverse of A, which is still going to give us an identity matrix. Boom. Did you see that, Jimmy? You threw that miles away. All right, guys, this is all that we have for you today. We've successfully proved that if A, B, and A plus B are all n by n invertible matrices, this holds. Till we meet again, don't do what Mama and I wouldn't do. See you soon.